Far in the future, there will be a moment when the universe produces its final light. Not the fading glow of distant stars, but the very last emission of energy capable of illuminating anything at all. After that moment, darkness will not just dominate, it will become absolute. The idea of a final light forces us to imagine a universe reaching its ultimate limit. Stars are the primary sources of light in the universe. They form from clouds of gas, ignite nuclear fusion, and shine for millions or billions of years. But every star has a finite lifespan, and eventually, all stars will exhaust their fuel. When stars die, they leave behind remnants like white dwarfs, neutron stars, or black holes. These objects may still emit energy, but they are far less luminous than the stars that created them. Over trillions of years, star formation will cease entirely. The raw materials needed to create new stars will be exhausted or dispersed, leaving the universe without fresh sources of light. In this era, known as the degenerate era, the universe will be filled with stellar remnants. Occasional collisions may produce brief flashes of light, but these events become increasingly rare. Black holes will play a major role in the late universe. As they consume matter, they can release energy, but over time, even these processes slow down as available matter becomes scarce. Eventually, black holes become the last significant energy sources. Through Hawking radiation, they slowly emit energy as they lose mass, producing extremely faint light over immense timescales. The evaporation of a black hole ends with a final burst of radiation. For the largest black holes, this event occurs after an almost unimaginable amount of time. This burst may represent one of the last flashes of light in the universe. After the final black hole evaporates, the universe enters a state with almost no sources of energy. Only low-energy photons remain, spread thinly across expanding space. These photons continue to lose energy as the universe expands. Their wavelengths stretch, becoming longer and weaker, eventually reaching levels where they can no longer be considered light in any meaningful sense. At this point, the concept of light begins to fade. There are no bright sources, no illumination, only faint traces of energy drifting in an almost perfect vacuum. The last light that will ever exist may not be dramatic. It could be a weak, final photon emitted in isolation, unnoticed and unobservable in the vast emptiness. After that moment, darkness becomes total. Not the darkness we experience on Earth, but a complete absence of any detectable light. Time continues, but without light or events, it loses meaning. The universe becomes a silent, unchanging expanse with no structure and no activity. Some theories suggest that quantum fluctuations could still produce tiny bursts of energy. However, these would be extremely rare and unlikely to create lasting light. The last light that will ever exist marks the final trace of energy, capable of revealing anything at all. After it fades, the universe enters an eternal darkness where nothing shines, nothing moves, and nothing remains to illuminate existence.